Hi everyone. So how do we ensure that our SCADA based radio network is going to really deliver like a high reliability network to us? So this is probably a good time to tell you about myself. So I've been doing this for 30 years, and a rough breakdown of that, the first 10 years was largely bench work, so setting equipment up on the bench. The next 10 years was largely field work, and then the final 10 years of that has been SCADA and electrical work, so in wastewater, water effluent, pumping stations, treatment plants, and reservoirs and the like. So I started out with a 4-year apprenticeship as a radio and electronics technician. Then I completed my second apprenticeship as a control systems electrician, working in that water, wastewater and treatment plant area from then all the way till now. So that being said, I thought the best way to answer the question of how to put together a radio base station polling loop that deals with all the issues we've discussed earlier was this hands-on video. So I hope it works. So let's get started. So we start really with an antenna selection. So you can see this antenna here, a binary array. It's a great choice of antenna. We do have, I might just move it back. It's 2 antennas in one. It's a binary array. We've got a lower and an upper pair of aerials, and this makes it really easy to come up with the solution that we're going to use to have high reliability in our network. And the solution is multi-coupling. So we're going to use this single binary antenna to cover what 6 antennas were doing before in that mast, or 5 antennas, or 2 antennas. And what that does straight away by selecting something like this, and I'm going to install it, so I'll get it out of our way. So this guy's going to go up. It gives us, really, it kills tower utilisation problems, because your antenna is going to be right at the top of your mast. It's going to give you the best of both worlds. It's going to sort out your tower loading. It's not labour intensive because we only install it once. And multiple transmitting antennas on a site is just a horrible thing to have. So for intermods and mixing problems and all those noise issues that we've got. So what we're going to do, I'm going to hook it up to a system that you've probably got already running. So most of you guys out there are going to have a duplexer. So this guy here, you're going to have a single antenna connection, and I'm just going to connect it to the lower antenna in this point because it's going to make the video a little easier to run through. And then our base radio, so the hub for our SCADA network. You can see here I've got an isolator or a circulator next to my duplexer, and these things are great to reduce transmitter to transmitter modulation, because these guys act as a diode. So the most common interference I see out on sites, generally in the earlier days before we started using stuff like this, or before I got involved in this area, was transmitter to transmitter noise, where 2 transmitters will run, one with the transmitter frequencies will just shoot straight into the radio, mix inside that finals stage, and then just retransmit out broad sprays of noise that give you really horrible intermod and noise problems. So what you'll have, your duplexer is just going to be connected to your base radio, transmitter and receiver. So as a first step, select a binary array, hook it into what you've got. Just pick an element, hook it in, and you're up and running. So that would be the first part of what I'll be looking at. And even if it's a greenfield site, this isn't a bad way to get moving. Now, we want to make it easy to expand. So every time you have to hook up a system where you're using individual antennas, new antenna, new feeders, new duplexer, obviously new radio, because that's an inescapable part of it. And that's up to a lot of coin. So you're probably spending, between 5 and 10 grand every time you add a channel. Now, what we do with a multi-coupling arrangement is this. We have essentially a receiver splitter. So this receiver now, this receiver antenna, this upper guy, I'm going to disconnect this. And I'm going to show you one of these I've done recently in a minute. So we're going to call this our receiver multi-coupler, which is essentially a filter that is a bandpass filter that just lets our receive frequencies run in the area that we want. So that will generally be about 5 megs wide. And then every time we have a receiver, it's got a number of ports on it when we install one of these. And I buy the 8-port multi-couplers because even then, when we've got a fully loaded system, we've got our 6 polling loops all running various radio equipment up there, I've still got 2 spare ports. So when I'm going up there doing my servicing, I'll just plug the spectrum analyzer into a spare port. If I'm testing receive signals and doing maintenance, I'll plug my comms analyzer into a spare port and do all my generating through that bandpass filter pre-selector arrangement. So I'm going to disconnect that transmitter, and here we go. I've got my bandpass filter and my imaginary splitter coming out, and my first radio. Now, we want to add another polling loop. So I get my second base station radio and install that. And all I do is plug a cable into my receiver multi-coupler, 8 ports here. I'm only using my second port and plug it in. Guess what? That's done. So this $1,000 we spent here is like the best $1,000 we've ever spent, because we've just installed as many receivers as we want just by connecting the cable. So that's really easy. Now the transmitters are a little different. Put another piece over here. Once again, we've got an isolator or a circulator, depending on what you like to call these guys, and a transmitter cavity. So this arrangement here, which instead of buying a duplexer every single time we do a station, we just buy another cavity. So the first transmitter, and I'm just going to put it up here, I'll even hold it down so we can see it a little easier. Here's our first site. So I go to my lower antenna for all my transmitters, and I'm using my upper antenna, my upper array for my receivers. And that being said, is generally because we're dealing with really small signals back at the base station. So I want to have, even though there's only really a dB or 2 in it, I want to have that receive antenna right at the top, and my transmit pair of antennas here, they can be a little lower because we're dealing with high power. Now, my lower antenna hooks up to my first cavity. Simple as this. We've already done all the hard work. This guy here is on our lightning protection device connected to our lightning protection earth. I connect my first cavity. My cavity goes to my isolator, which stops transmitter to transmitter noise, which is, like I said, a horrible thing, but an easy fix as well. Circulator can be a great thing. And then we hook up to our transmitter. So once I've got this system, and I'm going to try and spin this around so the camera can capture it, the next time I want to add a transmitter, all I do is bring up the people we bought the first cavity from, whoever your supplier is, say, I want to add one, no worries, give them the frequency, and they just send you out this kit. So every channel from this point on might cost you, I mean, round terms, $1,500. That's it, $1,500. This guy turns up, you connect into your spare port here, right? Add a second cavity, connect up your transmitter, the job's done. So the hardest part of the job then is actually doing what you're supposed to be doing, and that is getting your polling loops working, getting your equipment installed. So the radio side of things will be the easiest part of your system. And when you've got a system like this, you've solved receiver descents, because you've got this huge separation. Like, you're using a separate antenna for your receiver and a separate transmitter, a separate antenna for your transmitter. It sorts that out. All the noises we talked about before, all the intermods, low PIM, it's all done. So if we hold it there, Okay, so this is an installation that's actually live and up and running. And if we have a look up here, we can see I've got my top array and my bottom array. I've got a similar antenna. It might not be exactly the same as that antenna that I showed you, but it's a binary array. We've got our lightning protection earths connected to our lightning protection and our surge devices. And what I was saying before, where that upper antenna connects into our pre-selector, so our splitter. So that guy just looks just like this. So we've got a little amplifier, not for gain, just so we can ensure that all of the connected devices have 0 dB gain, so they're just at the correct level, and the bandpass filter. And if we come in there, we can see our transmitters hooked up. So there's our transmitter cavities. This started as a single site with a duplexer and one radio, and then as it became more and more popular, as you can see here, we would have had the first system that was here, then we've got a second, a third, a fourth, and soon to be a fifth. This will be expanded again to another network system that needs to be connected to this antenna. And it's really easy. Like I will bolt that can in that I showed you before. I will bolt my radio in, I'll make a bit of space. I've made a bit of space here today so we can see what's going on behind there. And the job's done. Like it's really, this is going to take me a couple of hours to get a polling loop up and running. And that's the beauty of the multi-coupling system on top of all the problems we've fixed. And this will just run. So here I am for the back view of the cabinet. I'm just going to come out so you can see. I'm just having a look in there. I'm going to come in. I'm just going to show you those two elements of this system again before. You can see up the very top here. I can't really point. I'll circle it later, I suppose, when I'm editing this video. But you can see the top bandpass filter is connected, and then underneath it, I've got that 8-port multi-coupler that I was talking to you about, and each one of those ports just plugs into a receiver. I mean, look, you've just never seen a system where it's easy to hook up a receiver, and every time I add a new transmitter to it, I just buy a can, add the cable into the next spare slot, and there will be a spare connector up the front there, which you can see. Let's see if I can get in there. Yeah, so there's the spare. I'll add it in there, or I'll add it in the antenna end, depending on what I order when I order my cavity, and the job's done. All right, thanks guys.